So when we're looking at a phone or computer screen, it's easy to make out details like individual pixels if we kind of squint our eyes and look closely. But how close do we have to get to the screen before we can no longer distinguish the individual pixels? And what does this tell us about our eyes? How many pixels does the eye have? Well, the number of pixels in an image is known as its resolution. The higher the resolution, the more detail the image contains. Human faces, for instance, contain lots of detail. So they typically have high resolutions. If we take a picture of something with a low resolution camera, then the resulting image will appear blurry because there isn't enough information in the image to make out fine details. But what about our eyes? Can we see details that are smaller than a pixel? Well, yes we can. This is because although our retinas contain photoreceptor cells known as rods and cones, which we could think of as pixels, our brains play a big role in interpreting what we see. In fact, our brains do most of the heavy lifting when it comes to vision. The retina simply sends signals to the brain, which then interprets these signals as images. This means that if we could measure the detail we can see with our eyes, we would also need to measure the activity of our brains. In 1968, researchers sought to determine the maximum angle subtended by 2 points that just can be resolved by the human eye. The angle subtended by 2 points is basically how wide apart the 2 points are from each other as seen from the eye. The wider the angle, the further apart the 2 points are. Now you might be wondering why they measured the angle rather than the distance. This is because the distance between the eye and the object being viewed varies. So measuring the angle subtended by the 2 points allows us to compare the results between different viewing distances. Researchers calculated that the average human eye can resolve details that are 1 arc minute apart, where 1 arc minute is 1/60th of 1 degree. They came to this conclusion by having participants view lines of varying widths and then reporting which lines they could just barely resolve. Using this value, they were able to calculate the number of pixels in the eye. Now we know that the retina is roughly spherical with a diameter of about 72 arc minutes. This means that half of the retina is contained within a circle of 36 arc minutes. Researchers use this along with trigonometry to determine the minimum angle subtended by 2 points that can be resolved by the human eye, which was found to be about 1 arc minute. As previously mentioned, the 2 points need to be 1 arc minute apart for them to just be resolved. If they're any closer together, then they'll be perceived as a single point, and if they're any further apart, then they'll be seen as 2 distinct points. Using this value, we can calculate the number of pixels in the eye. We know that the entire retina subtends an angle of 72 arc minutes. And if the eye can resolve details that are 1 arc minute apart, then there must be at least 72 pixels in the retina. However, we also know that the retina contains both rods and cones. Rods are responsible for our ability to see in low light conditions and do not contribute to our ability to perceive fine details. Cones, on the other hand, are responsible for color vision and are the photoreceptors that are stimulated by light when we are looking at objects during the day. The cones are also responsible for our ability to see fine details. Rods make up about 90% of the photoreceptors in our retinas, but only account for about 1% of the total number of pixels. This is because rods are much less sensitive to fine details than cones. We can estimate the number of cones in our eyes by assuming that every cone acts as its own individual pixel. Since the retina contains approximately 72 million pixels, and since rods make up about 90% of the photoreceptors, we can estimate that there are about 7.2 million cones in each retina. Therefore, the number of pixels in one eye is approximately 7.2 million. However, this is just an estimate. The actual number of pixels in the eye may be higher. This is because some photoreceptors in the retina are connected to multiple ganglion cells, which then send signals to the brain. So the number of ganglion cells in the optic nerve may be a better indicator of the true number of pixels in the eye. Studies have shown that the number of ganglion cells in the optic nerve of rhesus monkeys is about 1.3 million. Since rhesus monkeys and humans have similar eye structures, it's reasonable to assume that the number of ganglion cells in the human optic nerve is also about 1.3 million. This means that the number of pixels in one human eye could be as high as 1.3 million. So how many pixels does the eye have? Well, it depends on what you mean by pixels. If you mean the number of photoreceptors in the retina, then the answer is approximately 7.2 million. But if you mean the number of ganglion cells in the optic nerve, then the answer is about 1.3 million. And if you include both eyes, then the number of pixels in the visual system is about 2.6 million. We should also note that the number of pixels in the eye is not the same as the number of pixels in an image sensor or display. Image sensors and displays have a regular repeating pattern of pixels, whereas the photoreceptors in the eye do not. Also, image sensors and displays have a rectangular shape, whereas the retina has a circular shape. Despite these differences, the number of pixels in the eye provides a useful way to compare the resolution of our eyes with the resolution of cameras and other imaging devices. For example, the iPhone 13 Pro Max has a resolution of 27,078 by 12,84 pixels, which gives it a total of 35,038 million pixels. This means that the iPhone 13 Pro Max has about 10 times the resolution of the eye. It's also worth noting that the resolution of our eyes is not constant and can change depending on factors such as lighting conditions and the size of the pupil. In general, the darker the environment, the more our pupils will dilate and the lower the resolution of our eyes will become. But why does the resolution of our eyes decrease in low light conditions? This is because in dim environments, our pupils dilate to allow more light to enter the eye. This results in a phenomenon known as the dark current. The dark current is an increase in the noise level of the photoreceptors, which makes it harder to distinguish between light and dark. This is because when there's more noise in the photoreceptors, it becomes more difficult to determine whether a particular signal is due to a photon of light or just random noise. Interestingly, the dark current is what allows us to see in the dark. This is because in dim environments, our rod cells become more sensitive to light. This is a process known as dark adaptation. Dark adaptation occurs because in the dark, the rods undergo a chemical reaction that makes them more sensitive to light. This process takes several minutes to complete. So if we go into a dark room, our eyes will not immediately be able to see in the dark. We have to wait for our rods to become more sensitive to light. Another factor that affects the resolution of our eyes is the size of the pupil. The smaller the pupil, the higher the resolution of our eyes will be. This is because a small pupil creates a smaller image on the retina, which makes it easier to distinguish between fine details. The size of the pupil is controlled by the amount of light entering the eye. When there's a lot of light, the pupil will constrict to reduce the amount of light entering the eye. This will increase the resolution of our eyes, but it also means that we won't be able to see as well in low light conditions. So the next time you're looking at a phone or computer screen, try squinting your eyes. You may be able to make out individual pixels, which are the tiny squares that make up the image. These pixels are similar to the photoreceptors in our eyes, which are the cells that allow us to see. The number of pixels in an image determines its resolution, which is a measure of how much detail the image contains. The human eye has a resolution of approximately 2.6 million pixels, which is quite a bit lower than many modern displays. However, the eye is still able to produce a detailed image because of the way that our brains interpret the signals from our eyes. Thanks for watching till the end, and I'll see you in the next video. Thanks for watching till the end, and I'll see you in the next video.